It's funny, the ground beneath our feet feels so solid, so permanent, right? But the truth is, our planet is anything but still. It's in a state of constant, really dramatic change. Today, we're going to pull back the curtain on the incredible forces that shape our world and the amazing story of how we figured it all out.
So, what are they? What are these massive, invisible forces that are always at work sculpting everything from the tallest mountains to the deepest oceans? This question stumped scientists for literally centuries, and the answer? Well, it's pretty spectacular.
Okay, before we get to the big reveal, let's start with a quick quiz. True or false? Earthquakes and volcanoes just happen randomly, anywhere, anytime. What do you think? It's a really common assumption.
Yeah, that's going to be a false, for the most part anyway. While we can't predict their exact timing, these events are absolutely not random. They happen in very specific zones all around the globe. And understanding that pattern, well, that's the key to the whole thing.
And that brings us to the main event, the planet's puzzle pieces. See, to figure out why volcanoes and earthquakes pop up where they do, we've got to understand what our planet is actually made of.
So here's the deal. Earth's outer layer, what scientists call the lithosphere, isn't one solid shell like an egg. It's actually cracked into a bunch of enormous, interlocking pieces. We call them tectonic plates. And here's the crucial part. These plates are always moving. Incredibly slowly, but always moving.
So what's powerful enough to move a piece of crust the size of a continent? The engine is deep inside our planet. Think of it like a giant pot of water simmering on the stove. The intense heat from Earth's core creates these massive, slow-motion currents in the hot, gooey mantle below. And these currents drag the plates on the surface along for the ride.
Okay, so we know the plates are moving, but what happens when they bump into each other? What happens at the edges? To get a handle on this, we can actually use a really simple model that works surprisingly well.
In fact, you could do this in your kitchen. All you need are some graham crackers and frosting. The frosting is going to be our hot mantle, and the crackers, well, those are our tectonic plates.
So there are really only three main things that can happen at these plate edges. They can pull apart, they can smash together, or they can just slide right past each other. With our crackers, if you pull them apart, you can see the mantle frosting welling up in the middle. If you push them together, they crumple up into mountains, or one slides underneath the other. And if you slide them side by side, you can feel the friction, that tension building up.
Let's put some real names to what we just saw. At divergent boundaries, where plates pull apart, you get new crust forming, like the Mid-Atlantic Ridge. At convergent boundaries where they collide, you get these huge mountain ranges like the Himalayas. Or one plate dives under another, melting and fueling volcanoes. And finally, at transform boundaries, they grind past each other, building up all that stress that eventually gets released as an earthquake, like along the San Andreas Fault.
This whole idea feels so obvious to us now, right? But it was once a completely radical, out-there idea. And its story really comes down to one visionary scientist who just dared to see the world a little differently.
Let me introduce you to Alfred Wegener. Back in 1912, this German meteorologist came up with a wild theory he called continental drift. He actually suggested that the continents weren't fixed in place, but that they had drifted across the face of the Earth over millions of years. And his big aha moment was so simple but so profound. He was just looking at a world map and noticed how the coastlines, especially South America and Africa, looked like they could just slot together like a giant jigsaw puzzle. And it wasn't just the shapes. He found matching fossils and rocks on continents that are now thousands of miles apart.
So, based on all this evidence, Wegener came up with this idea that all of the Earth's continents were once smushed together in one giant supercontinent. He even gave it a name, Pangaea, which means all lands.
But here's the thing. Even with all his evidence, the scientific community just shot him down. They basically laughed him out of the room. For decades, his idea was dismissed because he couldn't answer one big question. What force could possibly move entire continents? It wasn't until the 1960s, when new technology finally let us map the ocean floor, that we found the proof: seafloor spreading. That was the missing piece that proved Wegener had been right all along. It's just a great reminder that sometimes the biggest ideas take a while to catch on.
So, okay, it's a cool story, and we solved this ancient puzzle about our planet's past, but why does any of this really matter to us today? Well, the answers are actually incredibly important, especially when it comes to keeping people safe.
Really, it's all about this. Knowing where the plate boundaries are lets us know exactly where disasters like earthquakes and volcanoes are most likely to happen. That knowledge is absolutely vital. It tells us where to build stronger buildings, how to create emergency plans, and ultimately how to build safer communities in these really active parts of the world. So, let's wrap this up.
What are the big things to remember? First, the Earth's surface isn't solid, it's a dynamic mosaic of plates that are always moving. Second, when those plates interact, that's what creates mountains, causes earthquakes, and fuels volcanoes. And finally, the story of Alfred Wegener shows us that sometimes even the best ideas need time and new evidence before everyone gets on board.
So I'll leave you with a final thought to chew on. Now that you know the secret of plate tectonics, where on Earth can you look to see these powerful forces at work today? The evidence is everywhere, from the peak of Mount Everest to the fault lines in California. Keep your eyes open, and you'll see just how amazing and active our planet really is.